section in chapter 10, which is 10-8. It actually deals with probability. It's considered geometric probability, though, because it deals with spatial probability. Two different types. The first type is what you would consider a little bit more linear, and it's based upon the probability of visually what you would consider a line with links like this. If this was A, B, C, and D, and often this can actually be related to time because you can see time intervals in a linear fashion like this. We'll do a problem in a second. And if you were asked, okay, what's the probability of anything occurring between B and C there on the overall line segment AD? Well, the way you would write it is the probability of that S is on BC, and then you express it as a ratio of BC over the overall AD, and those could be put into numbers based upon the distances of those two links. So there's the example of more of a length type look of probability based upon lengths of objects. And I'll show you what I mean when I say it's generally more related to time. If you look at problem 2 in your book, it says you've got a commuter train that runs every 25 minutes. So 1, 2, 3, 4, 5, 10, 15, 20, one more, 25. So we can take that 25 minutes and put it into a segment like that, where you've got every 5 minutes, there's 5, 15, and 25. You can see some of the passage of time. But then the problem comes through and asks, okay, if you've got this commuter train that comes through every 25 minutes and a person that's going to ride the train arrives at any random time from time 0 to time 25, what's the probability that they will have to wait at least 10 minutes for the train? So the first step is figuring out where's the 10-minute wait from. Well, if they get in there anytime from time 0 over here to time 15, you'll notice if they get there at time 15 or beyond, they will have a 10-minute wait. So we're trying to find the probability that they will have to wait for at least 10 minutes, which means they would have gotten there at time 15 or before. So you can see that the probability of that 10-minute wait, let's call it just probability of 10-minute wait. My writing's really tough right there. Let's see if that works. Is going to be equal to the segment 15 over the segment 25, which can be simplified down to divide both by 5, and you've got 3/5, but we would probably call that probability-wise 60%, and you would usually turn it into a percent, but just read the directions on Math Excel. All right, so that's more of a linear type probability problem. Again, a lot of times you'll see it with time. The other is an area or spatial type of probability problem. Here's the idea here. And again, from the book, they give you a trapezoid like this. And inside that trapezoid is a triangle. The trapezoid is titled trapezoid R. The triangle is N. I'll see if I can get an N in there. I may not have drawn it big enough, but that triangle is N. And so the probability that S is in region N, I'm going to leave out the word region, is equal to, well, just looking at it, what's the probability that there's a point within that triangle? You take the overall population, the population is R, and that's the area of R. So it's the area of R. That's going to be on the bottom because you take it out of the entire population. And then what's the possibility that S is in N? It's the area of region N divided by the area of region R. So you take the area of both, put them in a ratio, and see the relationship. All right, yet again, let me show you an idea of how this works. I'm going to have an interesting time trying to draw this on this, but I'll do the best I can. But we're going to do the problem in the book. And this one is problem number 4, using area-defined probability. We've got 5 concentric circles in a target. There's 1, 2, 3, 4, and then 5 would be one more on the outside. Now, obviously, which is unlike my own drawing, each one of these is supposed to be the exact same distance, and the distance all the way across, the diameter, is given. We're basically told that this has 5 colored scoring zones, and it's got a diameter of 122. So if the diameter is 122, the radius has to be 61. Okay? But then we're told that each consecutive concentric circle has the same distance here to here, here to here, there to there, there to there, and there to there. So that 61 is broken down into those areas. The radius of the yellow zone in the middle, the radius there, is 12.2. Okay. And every other section, all of these 5 sections has a radius of 12.2. Well, let's figure that out then. If they all have 12.2, what's 12.2 times 5? Interesting enough, there's our radius overall of 61. But then they say, what do we want to find? We want to find the area of the red, which is this zone right here. Yellow is the one in the middle, and then you've got black, blue, and white on the outside. So we're trying to find this shaded in area right here. All right. So to find that, we need the probability is going to be equal to the area of red minus because that red circle really is not a full circle. We have to subtract off the area of the yellow, which is the very center ring, over the overall area of the circle by itself. Now, the red ring has 2 12.2s. So it's 12.2 times 2, which is 24.4. So this is 24.4 squared pi, because we know that pi r squared is the area calculation, minus 12.2 squared pi over the entire circle, which is 61 for the radius squared pi. Basically, you can use your calculator to figure out all this. Let me see how I'm doing on time. Still doing okay on time, so I'll keep going, and we'll go ahead and simplify this down. 24.4 x squared is going to be 595.36 pi minus 12.2 x squared pi, 148.84 pi, all of that over 61 squared, which is 36 3721 pi. Now, obviously, everything has pi, so we just do 595.36 minus 148.84, and you end up with 446.52 pi. So I'll bring it over here, 446.52 over 3721. The pi's cancel out. So it just comes down to 446.52 divided by 3721, and you get 0.12, which is really a 12% probability of hitting the red target. So you just need to break it down and show your work. Sorry if my work is a little scattered on this, but you can hopefully see the breakdown of how I did it. This target type problem is actually fairly popular in some of the Math Excel problems, so I'm hoping that this problem will help you figure out how to do it. Just be careful when you switch from radius to diameter and back and forth. That could throw you a little bit. Hope this helps. We'll start preparing for that test soon. Look online and you'll see Math Excel has a Chapter 10 review quiz, which should help with each section. Talk to you soon.